This video covers the first part of Chapter 5 in EE160. We will be covering one-dimensional arrays in this video. Multi-dimensional arrays will be covered in a later video. This is enough for you to get your homework done this week. Okay, so one-dimensional arrays. Arrays are something that are helpful for programming because you can have, for example, an array of time data. If you were to try to import a file full of data into a program that you need to do some kind of a processing, you might have to try to assign a variable to every item in your file in order to do whatever calculations you have to do. But if you can assign the whole collection of data to one variable name, you can do other things with your program. So the arrays in C act to store the data under a single name. I can have a whole collection of time data and call the whole thing time. But each element in my data file has to be referred to by its position in the data file. That's called the index or the subscript. So as I say here, each data element that is stored, it's called an element. So here's some examples, and this is also how you declare an array. For example, here is an array of temperature data. So it's double, the data type is double. It's an array and it has 4 elements in the array. So notice when I make the declaration, I have to put these square brackets and say, in this case I'm saying how big the array is, and then I'm saying here are the values in the array, double numbers. I can have an array of characters. For example, here's vowels, a vowels array that has 5 characters in it, and I can define it this way. So going on, more examples, and also examples of different ways that you can initialize your array when you're making your declarations. There's the same temperature one from the previous page. Here's the same one for the vowels. This next line here, I have an integer array, and it has 100 places in memory allotted to it. So it can store 100 integers, but I only initialize it with the number 1. So that means my 100 spaces in memory are going to contain 1, 0, 0, 0, 0. All the other spaces will be initialized with a 0. I can initialize according to this next example. Int numbers, my array name is numbers. Here's again the square brackets to indicate it's an array. But I didn't say how big the array was, but the program will know how big the array is because I've initialized it with 1, 2, 3, 4, 5 elements. I can access an individual element in the array using the square brackets and the subscript or the index inside the square brackets. Notice, however, the indices or the subscripts start with 0. So this is element 0, this is element 1, 2, 3, and 4. And here I have it on a small table. So for the numbers array, numbers element 0 is a 2, numbers element 1 is a 1, numbers element 2 is a 3. So the index here is 3, sometimes called also the subscript. I can do the same thing with my character array, my array of characters. Vowels, element number 2 is 0, 1, 2. So vowels element 2 is an I. Strings. So strings are a bunch of characters put together. C does not have a string data type, unlike the more mature languages of C#, for example, or C++ has a string data type. However, we can kind of make strings that are arrays of characters. So here I have declared a character array. I didn't say how big it was, but I can put in double quotes all of my characters, and now I have an array of characters that says goodbye, cruel world. I sound suicidal. Not really. And then I can access one of the elements of the array by For example, string message element 0 would give me a capital G. If you just say, try to output a character and say string message and don't say an element number, you will get a compiler error. So you can do some operations on strings. There is a library that you can include at the top of your program to do some different string handling routines or functions. You just have to include this header file in your program. The C reference card that I gave everybody, right there, C reference card has the functions listed on it for character, but there's a little clip of it right here. String.h gives you some string functions. For example, back to my character string message that says goodbye cruel world. I already said I can print one character from it, but another thing that I can find out is the length of that string if I have this include statement. So string length, that's what that stands for, the function string length, and then you give the name of the array right here, which is string message, will return 19. There are 19 characters in this array of characters, and that includes the spaces, but it does not include the double brackets or double quotes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The quotes are not included, but the spaces are included. So why is that useful? Well, if you wanted to display that whole message, you could write a little for loop. You could figure out how long that array is with your string length function, figure out how long it is, and create a for loop that will print out each character in that particular string array. You can also use a loop to initialize the array. On the previous slide we initialized an array, but 99 of the spaces, memory spaces, were filled up with zeros. Maybe I don't want that. Maybe I want an array of 20 that's size 20, and I want 8 to be in every memory location. So I can use a loop to do that. In this case I've declared an array called myArray. It is 21 elements long. So when I do my for loop, it starts at k equals 0 and goes to k less than or equal to 20, which will mean 21 elements. Be careful with whether you start with 1 or start with 0. This is a source of off by 1 errors very frequently in programming. So in my loop now I say my array element k equals 8. So as k increments between 0 and 20, each space in the array each element in the array will be initialized with the number 8. And then I just printed it out to prove that that really is what it happens. And there's a clip off of my PowerShell. I'm using Windows PowerShell. So arrays are very commonly used to store information that is read from files, and then the program will get the information, put it in an array, and then the program can work with the information. The example I gave you earlier was using time data. So here is an example of how that might happen. So this first part of the program, I just do what I need to do to be able to open a file and read it. I also make the declaration that I need an array that's 10 elements long. In this example that I'm giving you, I looked at the file, the .text file, and I saw that it was 10 elements long. So I make a declaration to give me an array that's 10 elements long, and then I can read in the whole file. But I still use the end of file way for no, I didn't. So I read in my file using standard examples from the previous, I think it was 2 chapters ago, and I knew my file had 10 elements in it. So for k equal to 0 to k less than 10. That will be 10 elements. I read in a line of data, and the integer that I read, I store it. Notice that I store it in my array element number or subscript number k. So as k increments in this loop, data element 0 will get the first value read in, the first line read in. Data element number 1 will get the second line read into it. While I was doing it, I wanted to find the sum of the data that I was reading in, so each element is added to the current value of sum, and I can get the sum of the 10 data elements that I just read into it. After I read the whole file, I can do something else. For example, I can find out the average. Sum divided by 10, I knew it was 10, I could print the average. In this example, I knew how big the data file was. It was only 10 elements. But many times the file is very large. You can open up the file with your notepad or whatever program, and you can see what the data format is. Is it one column? Is it two columns? Is it doubles? Are they ints? What does the data look like? You can look at it and see that, but if the file is very large, you don't know how many lines of data there is in the file. And this is very often the case. So we would like to open and read in a file and put it in an array without having this foreknowledge of how big the file is. So my next example shows you how you can do that. So I just modify the previous example, but now I don't know how big the file is that I want to read. So here is the same part up front. I set up to read in a file. I do not know how big of an array I need to create, but I need to find out how big my file is. So this is how you would do it. So first, do I open the file successfully? If I do, then I continue on, and then I will read in a line of data, and each line that I read, I will put it in, I have to put it somewhere, so I put it in just a variable called data element for each element that I'm reading in, and then increment a count. So I have a while loop that just goes through and reads through the file and increments a counter. So this will determine how big the file is. Then I close the file. The trick with this example is you have to open the file, read in all of the lines and count the lines, then close the file and reopen the file and read it again to get the data. That is because as you read through the file the first time, to count how many lines there are in the file, the pointer to the file is at the end. So to bring, it's like a marker, you want to start back over again and read in all of the data and put it into an array. Now that I know how big the file is, but I have to go back to the beginning of the file to do that. And I cannot in this scenario. I can read it through once to count how many elements there are, but I cannot have put that into an array because I don't know how big of an array to make. I cannot just make an array and not know something about its size. I have to declare its size in some way so that the compiler will reserve that space in memory for it. So this is what I do. I open the file up. I read through it once. I count how many elements there are. I never really stored anything here. This got rewritten every single time it read a line of the file. Then I close the file. Then I create my array that I need because I want to put everything in the file into this array. But I know how big the array is now, so I create the array right here with this declaration statement. Then once again I have to reopen the file so that my pointer, my marker, goes back to the beginning of the file, and then I can read in each line of data. But this time when I read in each line of data, I'm going to take the integer of each line and I'm going to put it in an array. So previously I just took in an element. I didn't do anything with it. I just read the element and counted it. Next time I went through a loop, opened the file and went through a loop, I took each element and put it into an array. Array position 0, array position 1, array position 2, etc. Here I have a printf just because I was checking to make sure that it was really doing what it was supposed to do. That printf should be removed in the final program, but I was checking to make sure that I was indeed writing to an array. And then I can take the particular element that I just read and add it to my running total, my sum. And then once again, don't forget to close your file. Okay, so that's well and good, but now I probably could have done this without ever creating an array. So one of the advantages of putting the data in an array is that you could now call a function to do something with the data that's in the array, rather than if you read the data in one line at a time, it may be hard to do some kind of a function. So let's see how you can use functions and arrays. You can actually make the array be one of the arguments of a function. So you can define a function whose parameters are integers, whose parameters are doubles, whose parameters are characters. You can actually have a parameter that's true false, it's a Boolean. Or now you can also define a function whose parameters are an array. So I've defined a function right here. It's a function that's going to find the maximum value in an array of integers. So here is my definition of the function. Here is the header of the function up here. It's going to return an int, which is the maximum value. And when the main program calls this function, the main program is going to give it the array, and it's going to give it how big the array is. So see in my parameters right here, one of my parameters is an array, one of my parameters is an int, just a number. The actual value that gets used in the function when the function is called is it's a real whatever the number is. If the array is a size 20, then the number 20 gets passed into this function. The function does whatever it needs to do with the 20. When the array is put into the function doesn't take all of the data in the array and stick it in the function somehow. What the function does is take the address where the array is located, and then when you go into the function is going to do something with elements that are at that address, beginning at that address. So this is a starting address where the array is stored in memory. So a function call, the main program calls this function. Calling a function and putting some number into it is a call by value reference. So that you're actually putting a value in there. This value that's in memory somewhere, whatever it is, maybe it's the number 20, it can't ever change. It sits in that memory location and it doesn't change. Well, actually there is a way to change it, but it's not considered good programming practices. So that value, say it's a 20 sitting in memory, is the exact number that's passed into this function, and the function will do whatever it needs to do with that value. This is an address. So we say this is a call by address reference. So when you call this function, invoke this function is going to be using an address right here of where the array is located. So let's look at my find maximum function. So I want a maximum of some array, and I don't really know anything about this array except that it's integers, and I know how big it is because maybe my main program figured out how big it is. But I want to find the maximum of it, so I need to find some max. So I declared a variable that's local. Remember, it's only local to this function. Max of some array has no meaning outside of this function. It would not be recognized. So I make some declarations here. Looks like K is an iterator. IJKs those are good iterators, but something with meaning should have a meaningful name. I say that the very first element of the array, element 0, is my maximum number. Then I go into a loop, a for loop. Well, I could have started at 1, I guess. If the current element from the array is greater than or equal to the current maximum value, then the maximum value will get that value of that current element. And I'll go through the loop every single time, and if the next element I get is bigger than the current maximum, then the current maximum will get that value. And then the function returns whatever that maximum value is. So let me show you an example here. I'll finish up the rest of that program. So this was the program I showed an example of before, of having, maybe you have a very large file, you don't know how big it is, you want to read it in, so I have a while loop that reads it in and just counts how many elements there are in the file. Then I close the file, reopen it again, I run through the file a second time, only this time I put each element of the file into an array called data, and while I'm at it, I sum up all that data so I get my sum, and then I close the file. And then I have these printf statements. The sum of the array is, well, I got sum up there, so that was easy. The size of the array is, I'll say what the size is because the first pass through the loop I counted it. And then I can find the average of the array, which would happen to be the sum divided by the count. Everything was an integer, so I have to cast it into a double. That's all fine and dandy. Then my last print statement says the max of the array is, which should be an integer answer, and I said find max, and I passed the array to the function. My array was called data. The size of data is right there, this value called count. So now let's look down at my function. It's the same function that I had in the slide, but it's nice to see what's going on between this line right here and the function that's down here. So notice in my function header has a parameter called SumArgument, that is an array, and a parameter called size, that is an integer. I changed out of n to size from the PowerPoint slide. But when I call the function, the values that I pass to the function are data, which is an array, and count. So data and count are not the same names as these parameter names that are only recognized inside this function. As I mentioned in the previous YouTube, some people missed that point in the midterm exam. So these are just variables that you create for the purpose of this function, and they only exist in this function. And I can pass whatever I want to it. The function gets the address of data, and the function gets the number that is stored in count, however big my file is. And then the function down here will go through that routine that I just explained and find the maximum of the array, and then return some kind of a maximum. So let me exercise this. My file that I'm reading is called I defined it earlier. There's an earlier part of this program where I actually create the file. I'll go ahead and show it to you. So I create a file, then I close the file, then I read in the file and do all the processing. So here's the rest of my file. So the first part of the file, I create a file, I write to a file, and I just write random numbers to it. So in this case I'm writing 20 random numbers between 1 and 100 to the file. But what if it's big? What if I had 500 random numbers in a file between 0 and 100? It's actually between 0 and 100. That's how big my file is now. So I write this file, I create that file, and then I close it. Next part of the program, I open that file, but I don't know how big it is in this part right now. So I'm just going to open it and count how many elements are in that file. Then I'm going to close it. Now I know how big the file is. I'll create an array. Then I'll reopen the file, read all of the data that's in the file into my array, and my array is called data. And while I'm at it, I'm going to find the sum. Then I'm going to close the file. Then I'm going to output this information, and part of this information is finding the maximum of the data. So then I have this function that finds the maximum of the data. Okay, let's run it. Yeah, let's clear all this stuff first so it's clear. All right, now let's run it, compile it, and run it. Oh, there's my big data file. Oh, that was a test there. But it says down here at the bottom, the size of the array is 500. The average of the array is 49.874, which sounds about right. I mean, the average, the numbers, there's 500 numbers between 0 and 100. The average should be pretty close to 50. The maximum value of this particular array is 99. Well, that's a surprise. Oh yeah, between 0 and 100, the maximum value will be 99. That is correct. All these numbers, other numbers up here, was me having a printf statement that was troubleshooting when my program didn't work right the first time I wrote it. And that's this statement right here. So if I want to get rid of it, that extra printf where I was checking that things worked right, I will run it again. While I'm at it, why don't I not print out 500 lines of data as I create it? Yeah, let's not read out the 500 lines that I create. So save it. We'll run it again. Actually, let's clear so it looks nice. Run it again. Compile, run. So there we go. The sum of the array is a big number. The size of the array is 500. We're good. Average of the array is 49 point whatever, and the maximum is 99. Notice in that creation of random numbers that 100 was not included. It was integers between 0 and 100, so 100 is not included in there. Anyway, happy with that. That does work correctly. So this function will do that for arbitrary size. So your homework has something very similar. I am going to give you a file. I gave you a file that you don't know how long it is, and if you open it up, you will see that it looks like lots and lots of numbers. And you will have to read in that file and read it into an array. You will have to find the maximum and the minimum and the sum of the numbers and the average, I believe, and output that to the user. I think I asked you to write a find max and find min function that you pass an array to. So similar to this lecture with a little bit more, but it's time for you to do it yourself. Okay, only 2 problems this week also, since you just had a midterm. Bye now.